So, rules of thumb. We're talking about population proportions, so we're talking about categorical data. Our prime example is political polls where you've got 1,000 people and you're saying who's going to vote for Labour or National or what have you. So the big idea is sample statistics only give us an educated guess about the population statistics. They're only sample statistics, we're only getting an estimate. But newspapers often report the sample statistics as if they're the population parameters. So they'll say, sample of 1,000 people, 23% said they'd vote for the Greens. And then in the fine print, you've got the sample size, which is an indication of accuracy, but it ignores any non-sampling errors, meaning that they only asked people who were green in the first place. The rules of thumb are very quick ways of getting a better idea of how accurate the sample statistics are, but they're only taking into account sampling variability. They're not taking into account non-sampling error. And also they don't take into account population size. So if you had a population of 100 and you took a sample of 100, you've got the entire population, so you'd be 100% accurate. It just ignores that. And it says, okay, 1,000 people is enough to get a 3% margin of error. They're very rough. We worked out proportions that are less than 30% or greater than 70%. They're not so accurate anymore. Here they are. A population proportion. I've put the 100 there because if you got 100 divided by root n, you've already got the percentage. You don't have to then convert it to a percentage. So 1 over the square root of n gives it to you as a decimal, and for a sample size of around 1,000 you get 0.03. If you do this you get 3%. Okay, so that's your margin of error. So for Labour, if it said that Labour got 45% in the poll, that means back in the population we can be 95% confident that it would be between 42 and 48, because with 1,000 people 1 over root n would be 0.03 or 3%. The other thing is when you're comparing the difference. If you're comparing the difference and it's within the same sample, you're actually 200 over root n. So you take the difference of who votes for National and who votes for Labour. If that difference is 10% and your sample size 1,000, it's 10% plus or minus 6%. You actually need that doubled. The other thing is when you've got a different sample, and the big hint here is you get 2 n values. So you might have a poll 3 months ago and a poll today. They both might have a sample size of 1,000, but they're actually 2 different sets of people. So if you've got also 2 different groups within the same sample, males and females, they are treated as 2 separate mini samples, if you like. So when you're doing that, you do 1.5 times the average margin of error. Now, why is that bigger? The only thing that I make sense of it is that if you're looking at, say, Labour National, if someone changes their mind, it kind of doubles it. The other way of looking at it is to do with overlap, but overlapping of confidence intervals, but with this you would get an overlapping of confidence intervals and yet it would be okay. So there's quite a lot of deep maths there and deep thinking, but for the interests of passing this, you need to know these off by heart. Okay? Is that any good?